आज हमारा विषय ओवरव्यू ऑफ वेब जीआईएस टेक्नोलॉजी, ओवरव्यू ऑफ कॉन्सेप्ट्स, डेटाबेस, डीबीएमएस, जियोडाटा हैंडलिंग। ये लगभग 1 घंटे का लेक्चर है और इसके बाद जिन लोगों को भी क्वेश्चन डाउट पूछने हैं वो अपने क्वेश्चन लिख के भेज सकते हैं। इस लेक्चर के बाद सबके क्वेश्चंस के आंसर किए जाएंगे। इसके लेक्चर के लिए हमने 3 अलग-अलग पार्ट्स किए हुए हैं। We will cover the first part in which we will take care of about basic database, what data means, what types of database are, their characteristics, advantage and disadvantage. And sequentially we will move on about what WebGIS means and how this database is used for WebGIS applications. So we will start the first part, data. Well known fact is data is a collection of distinct small units information. It could be like text, image, or bytes, something which is written on electronic memory. It's also known as datum. In computer language, data is information that can be translated into a form of efficient movement and processing unit. So data is interchangeable. We can convert from one type of data to other type. Like image can be converted to sequence of binary units 0, 1. Database and database management systems. Database management systems are combination of data, their handling software, and small algorithms which are used to take care of data, store them properly in tables, rows, columns, and index them while you are searching for data. So such help will be provided by the management system about the data. When you are using data via the management system, then you will have advantage of searching, sorting, and finding data in a huge data set, and again converting them to useful format and display. So this all processing will be helped by the management system. So database alone is not used generally. It is always combination of data and its management system. So combinedly it is called database management system. There are many dynamic websites which are using these formats. In almost every website we will be using some database for a better functionality and storage. Database variables are helped in various formats. So database available like MySQL, Sybase, Oracle, MongoDB, and Informatics, SQL Server, all are there are variety of database. Some of them are this. There are still some more databases like NoSQL or huge databases like big data. So it depends on requirement, and based on the requirement we choose our database. SQL is the language, structure query language, which is used to take or dig the data from the database. So it's like saying the management system about searching the data and giving the user the database. So data, when we are searching, we have to communicate with the management system that how data will be stored and it will be given to us. So this all is helped by the language called SQL. Database types. Database means is here I am conveying the database management system. So when we are saying database here, it's all combination of database and its management system. When we come to the types of database, there are many. One of them is centralized database, in which we have decreased the risk of data management. Manipulating data will not affect the core data. So these are the advantages of centralized database, in which basically the total database and its management system is stored at one place in a central unit, and every user is allowed to access it based on its requirement, and there are communication systems to control the access of data. So the security and access control are implemented on the centralized database system, which user want to access, he should have the proper access rights. And this everything is managed by a central location, central services, and central management system. This had advantage of consistency. That means the data will not be inconsistent. Like there are some table modified, some data is consistent, some is not consistent. That means you have written some data, some other user has modified it again, and it is in half communicated state. So such is condition will not happen, because centralized repository is there, which will manage which user has to write at a time. And it provides better data quality, enables organizations to establish data standards, and less costly because fewer vendors or suppliers are required to handle the data set. There are disadvantages, like size of centralized database is large. When huge number of users are there and the data is continuously flooding. So disadvantages are it could not be fetched on time. If, for example, if the Google is using centralized database, they cannot serve. The frequency of users and the frequency of searches will not be taken care at their fast pace. So this type of database could not be used in such application. It's not easy to update extensive databases in case there is version change or new update have come. To implement those changes, it will take huge time, and that duration of update time, database may not be useful, or we have to take the database down. Third problem is failure occurs. In the central database, failure occurs, the entire data will be lost, or it will be a huge loss. But still, some places, central database is beneficial when you are a single user of data and your database is very small. It is always preferred to have a centralized database. For small websites, this is best thing. Now let's move to the second type, database which is distributed. Here the distribution system, data is distributed among different databases in the organization. Databases are connected via communication links, which helps them to make the database consistent. Example of distributed database are Apache, Cassandra, HBase, Ignite. There are again further division for distributed database like homogeneous and heterogeneous. Homogeneous in the sense that same operating system and use of same application process and carry the same hardware devices. Heterogeneous is combination, it's not dependent on single type of operating system and things. We can have multiple operating systems like Windows and Linux at the same time to hold the data, and their applications also could vary. So there is different method used for heterogeneous database system. Advantage of distributed is it's modular. Development is possible in a distributed database. The system can expand by including new computers and connecting them on the fly. One server failure will not affect the entire data. So this type of database system, like distributed database system, is useful in many other applications. These are the categories. Third type could be relational. The database is based on relational data model, which stores data in form of rows. Rows are also called tuples, and columns are called attributes. In the language of computer database, we call the rows like a Excel sheet rows as a tuple. So this language we will be using this type of words, and this combination like the total table which contains username and their relation things, that is called relation. So the complete table is also called as relation. A relational database uses SQL for storing, manipulating, as well as maintaining the data. As I told, that SQL is a sequential query language, structured query language, which is used for communicating with database. EF code is the known as inventor of this database system called relational database system in 1970. The key that makes the data unique from others. Each table must have a key which makes the data unique from others. Examples are MySQL, frequently used database system, Microsoft SQL Server, Oracle. So potential properties of relational database are mean atomicity. We called it combination as acid properties. The database which follows acid properties are called relational database as per the EF code rules. So here acid, A means atomicity, C means consistency, and I means isolation, D means durability. How these are different from each other? Atomicity is when we ask for a modification in database, then it will be atomic in sense either the complete database operation will be done or the operation will not be done. It could not be a partial transaction or partial operation on the data. Like if there is bank transaction for a user, he put the ATM card and want to take out money. If he puts 10,000 rupees, then either the complete 10,000 should be deducted from the account and distributed to him, or the complete 10,000 should be denied. So this is called atomicity. There could not be like you applied for or asked for 10,000 and he gives you ATM machine gives you 5,000. So such things should not happen. This is one example of atomicity. There are many day-to-day operations on database in which atomicity is considered very serious activity. Otherwise, database will not be in the position of usable. Here, consistency is performed any operation over the data. The value before and after operation should be preserved. For example, account balance after and before transaction should be correct. In case you have deducted 10,000 from your account, there should not be again partial update, or the database like in earlier you have 1 lakh rupees and now 10,000 deducted should remain 90,000 because 10,000 reduced. But such thing, if consistency is not there in database, then your transaction will happen again instead of 90,000, it will remain 1 lakh or it may reduce to 80,000. So such things would not happen. That is the consistency of database that is maintained by the relational database. So these are the properties which ensure that your databases remain in proper state and usable. I means isolation. In case 2 or 3 people continuously operating on same database table, therefore the table should be or the relation should be in proper state. So one transaction effects should not be visible to other transaction in the database. Like 2 people are removing or taking out some rupees, some 5,000 rupees each one. Then it should not be like for first person it shows 80,000, other person it shows 85,000. And when it is reduced, total state should be consistent. So atomicity, like each operation either done or not done. C means consistency, before operation and after operation, the data should be in consistent state. And isolation means multiple operations on the database should not affect each other. D means durability. That is again ensure that once the transaction is completed, the operation is completed, and data is committed in the sense like the database is written permanently. So the permanent writing in the database is called commit. So data change should remain permanent. Like once it is committed, final transaction amount should be permanent. It should not be again modified or reverted back. So such conditions are ensure that the durability is confirmed. This is one example of ATM which we have taken here, but there are multiple operations continuously on the websites for which all these ACID properties are taken care when you are using MySQL as a database for your website, or Microsoft SQL, or any database which is relational. Another type of database is SQL, NoSQL, where we call it not SQL. So it's little different in several ways. Like there is no tabular format of storing the data. So there is no, as per the EF code, there is no relation in this database. But how it is different and how it is used. So let's see something better perspective of it. We can further divide NoSQL databases into 4 types. Key value storage. It is simplest type of data storage where it stores every single item as a key, holding its value together. So it's like a two ways, like a linked list type of thing, where one data set is connected to another data set and there is nothing more. Second type is document oriented database. This type of database used to store data as JSON like documents. It helps developers to storing data by using same document model format as used in the application code. So the document is stored as a application, like a computer program. The third type is graph. It is used to storing vast amount of data in graph-like structure. Most commonly, social networking websites are used the graph database. In which graph database we have links connected from one branch to another branch from it may be a long list of one user. Like single user has Facebook account, he has liked something in 2010, and then onwards first creation of his account on Facebook, everything is linked to his account. So this is one example of social networking website where graph database is used. Wide column storage is the fourth category of NoSQL. It is similar to data represented in relational database. Here data is stored in large columns together instead of storing in rows. So it's one line of format. There is no rows in this type of storage. There are many advantages of NoSQL, because of which this NoSQL has become famous and people are using it continuously still. There are many other variants of NoSQL. So let's see the advantage. It enables good productivity in application development, as it's not required to store data in a structured format. So it's like you have dump of files in your IIRS. There is nothing is kept in a format like the file starts with A will be in the first column, second B should start, not like that. Anything you can put anywhere, but they are linked in some other way. Second thing is it's better option to managing and handling large data sets. This is one application like Facebook or Google or such type of huge database sets where people or database system is not having time to manage your queries or your requests. So users are millions of users continuously using each second. So such things we cannot do, like categorizing them, indexing them, and keeping them in some place. What happens is, as and when the query comes, as it is, it will be placed. So this is better option to manage or handle the large data sets. It provides high scalability. As the requirement grows, the servers scalability means the new hardware, new software could be placed at running time. So when we are running a website, if the requests are high, we will scale it to more. When the requests are less or load is less, we can reduce some hardware. So this happens online, or in a little time is taken to downtime is taken to scale the software and hardware. So these are advantages. Another advantage is quickly access data from database through key values. So once the user ID is known for a Facebook user, you can just click on that and you go through this timeline, everything is visible there. So based on the key value, everything has been taken from the database. These are the advantages of NoSQL. These are the 4 types. Another type of database is cloud and hierarchical. Cloud, like Amazon Web Service, Microsoft Azure, and many others. Google also have Google Cloud. This type of database is where data is stored in virtual environments and executes over the cloud computing platforms. It provides users with various cloud computing services like program as application, programmers, infrastructure, and softwares which are used as a service. So when the software requirement grows, new software, new version of software, or number of users of the software can be increased online or based on the requirement. So based on the type of service, computing service you are using from taking from the cloud, we can increase or decrease, reduce, or even speed up the processing. So these are, everything happens online. So we well known word use the cloud for this purpose, because it is not known that how many servers are being used for your website. If you have hosted a website on Amazon Web Service, you will not be knowing how many hardwares, processors, or hard disk size are used for this purpose. So based on your requirement, it grows. When your website having more load, it will be continuously grown and increasing the service amount, the speed, network speed, everything will be increased. And based on the load, if it is reduced, the same way the service will be reduced. So this happens on the fly online, and there is no or very little manual intervention during the process. That's why we call this as a cloud. For accessing the database, there are numerous cloud platforms, and there are various options for them. Like if you want to use for a year, or you want to use for 10,000 users for a month. So everything depends. Like if you are going for a Amazon Web Service cloud for your website, you can go for either based on time. Like for 1 year I want to use, then rate will be different. But there will be limitation in the users, on hardware size, and the speed, the network capacity, and the hardware storage. So based on all these things, your cost will increase or decrease. If you want to have more size, like you want to host movies on your Amazon Web Service website, in that case, for hosting the movies, the size of storage will be increased. So the cost may vary. The same person, if he is using another website for same Amazon Web Cloud service, and he is not having movies, he is using simply few images or a single page website, then the cost will be less. The minimum cost will be greater. Another type of database is hierarchical database. This type of database stores data in format of parent-child relationships. So there is like a tree structure. It's like an organization, government organization or private organization, when the structure is as a format of tree. There is some leader of the organization, then there are subordinates, then further subordinates. So this type of structure, child-parent structure, is called hierarchical structure. Data gets stored in form of records and connected via links. Each child record in the tree will contain only one parent. And on the other hand, each parent record can have multiple childs. This is called hierarchical database. There are many other, some of them like object-oriented database. This type of database uses object-oriented data model approach for storing database. Another is network database, where database typically follows the network data model. So representation of data in form of nodes connected via network link. So this is little different than hierarchical. What are the key characteristics of database? So database management system uses digital repository established on a server to store and manage the information. It can provide clear and logical view of process that manipulates data. It means you know via which process your data is being read or modified or deleted. Database management system contains automatic backup and recovery procedure. It contains asset properties, as I explained in last slides, which maintain data in healthy state in case of failure. It can reduce the complex relationship between data. So we use normal forms for this purpose. It is used for purpose manipulating and processing the data. It uses to provide security of data. These are the key characteristics. It means every database management system should have these features. In one way or other, via some software links or via some commands, you should have these properties. So it can view the database from different viewpoint according to the requirement of user. So these are the key characteristics of database management system. What are advantages? Control over database is the key. So we must have the control on the database. To control the database redundancy, it can control data redundancy because stored in a data in one single database file, and that record data is placed in the database. So duplication of data should not be there in the database. These are the advantages. Like in case if you're storing in same thing or your student records in Excel sheet, some of the Excel sheet records may be duplicated in few people or few students of your record. For example, they are admitted in last year, 4 years back, 10 years back, 15 years back. Again, they have come. You have made one more file, and you have created one more Excel sheet, and same names are repeated. So in such cases of such example, there is repetition of data. So redundancy is still existing. In case of database management system, if you're using for this purpose, redundancy could be removed. Data sharing, in case you want to share data between people, then you have to copy the Excel sheet in different format, or if it's a Word document, you have to copy and give them one copy. So such data sharing is reduced in case of database management system by providing an access username and password to the user. Whoever want to access the database, they can have username, password, and multiple users can connect. So there is no need to copy the whole database or a single file of database and give to them. You can simply create a username, password, and the user can connect from anywhere if it is connected via internet. And there is easy maintenance, like due to centralized nature of database. If you have to clean something, you have to delete something. If some user is gone, you can delete the username and password for them. Such maintenance is easy. But in case of old database, which is not the database management system, which is not a DBMS format like Excel sheet, in that case, if you are giving some data to somebody, that data remains with him. So these are maintenance issues. Another advantage is reduction in time. So development time and maintenance time is reduced in case of DBMS. Backup and recovery, both are easy in case of database management system. So which help us in case of hardware or software failure to restore the database from last key point. Multiple user interfaces are there. Different users can be allowed to access different type of user. So in case there is requirement to see, someone want to see only the part of the database. So a user could be created with limited access. So these type of control are there. User interface could be controlled via multiple users. Disadvantages are also there with database. The cost of hardware and software. In case you are using a small application only for purpose of 10 or 15 users, then database management system is not required. Based on size of disk or memory, how much you are going to use. Like in case database management system to host or hold 100 people record, you have to install a database management system which itself may be more than 1 GB. So these pros and cons you have to see, advantage, disadvantage you have to see while using the database management system. In case the huge database system is not required, like Microsoft MS SQL, Microsoft SQL system server, then you can use for small, like medium-size database systems like MySQL. Or if still your requirement is very less, then no need to go for MySQL also. You can manage with small, tiny database management systems also. Complexity is also there with the database. So this is again one disadvantage, as additional complexity is there to hold the data, because database is accessed via management system. So the management system has very complex structure, including different level of complexity. And last is higher impact on failure. In case it fails and the management is not properly taken care, like taking backup and storing on regularly, checking with whether the backup is working fine, all such things are not taken care in case of the database management system, the impact is very high in case of failure, because you will lose complete data set. And it's like unbearable situation sometimes. In case of banks and other things, we have to ensure that at any cost the data is available. So these are few disadvantages. Now let's come to the relational data model. This is our second part of the topic. So we'll see about the relational database history. What is a relational model concepts. I will cover in brief, as many of you may not be from the background of computer science or this computer background, so it may be a little difficult. But let's see in a later way, and your queries may be answered in the last. A brief history of relational data model, as I already told in short. E.F. Code has written one such paper in 1970. Based on his paper, he has identified few rules about the database. So the database which follows those rules is called relational database nowadays. There are, however, few changes, like he recommended something and which is not practically possible or which has some disadvantage that today has been modified now. So, but still it is famous name, so we keep on calling it as a relational database. Any relational database should contain some tables, which is also called relations, rules like constraints for how tables are arranged, and set of operators to act on tables. These are the three key methods. Now there are various data types for the database, relationship between tables and SQL queries like data definition language, data modification language, data control language. These are the part of structure query language. So examples are there, and indexing. So what is relational model? Relational is simple table values. If any database contains tables, which is row and columns, then it is called a relational database. Table name, column names are helpful to interpret the meaning of values. Example also I will show you below. Some popular relational database management systems are DB2, Informatics, Oracle, DB, SQL Server, and Access. Relational model concepts. These are the things which comes frequently during the relational model or relational database system. We call as a attribute. So what could be attribute in case of example? For example, we are taking care as a student. So student table, student roll number, student name. These are the attributes. Table, the name of table could be the student table. Tuple is the single row of a table which contains single record, like in the sequence number 10 there is a name Dharmendra, then his age or his qualification. So this could be one tuple. Then relational schema. The relational schema represents the name of relation with its attributes. So we call student, in bracket we will write name, age, like that. So we identify the total table and its columns in a single line. This is called schema. The scheme of database, a scheme of table. Then degree. Degree is total number of attributes. If there is 5 columns in the table, then the degree is 5. Simple. So again, cardinality, total number of rows present in the table. If it is a record of 100 users, then cardinality is 100. Columns, the column represents the set of values for a specific attribute. Relational instance, for a moment, if the 100 users or 100 students in the table are taken as a screenshot or photocopy, it is called a relational instance. Now, if some new user comes, it will be modified. So we call the relational instance of that time. It keep on changing. Now, relation keys, every row has 1, 2, or multiple attributes, which is called relation keys. Attribute domain. Domain is called the predefined set of values. Like for age, it could be 0 to 100. We cannot go like age is 200, 2000 something. So this is called domain of the attribute. So the age attribute has the domain of 0 to 100, and it could be only numerical. So this is like what are the values we can hold for that column. This is known as attribute domain. Now the example. we call this table as relation. There is primary key like customer ID, domain. I have taken from this the screen from guru99.com, and the status of the customer like Google is active, Amazon is active, Apple is inactive. Now these columns are called attributes. Total number of columns is degree, as I explained. Tuple or rows, number of rows is cardinality. So there are 3 rows, 3 columns. So cardinality is 3, degree is 3. Relational integrity constraints. Relational integrity constraints referred as conditions which must be present in valid relation. And there may be many types of constraints like domain constraint. Domain constraint I have just now explained about the age. Key constraints, referential integrity constraints. There are these constraints are followed to keep the database consistent and integrity. Domain constraints, as I explained, domain like customer name could not be null. And key constraints could be like in case of this example, Google is active, Amazon is active, Apple is inactive. So the status could not be something other than active or inactive. So this is constraint. This is called key constraints. The key, name as status, the attribute status could not have anything other than active and inactive. So there are only 2 options. This is called constraint. Referential integrity, when we are connecting with 2 tables or 3 tables, then becomes the foreign key concept. So in this example, customer ID is 1, 2, and 3. Google is the user, Amazon is user, Apple is user, and status are active, active, and inactive. When we are going for billing of them, now invoice numbers are this new table's keys. Customer ID is the key which is taken from the earlier table. So earlier table which are containing usernames, the customer names and their status. Now when we are using 1 and 1 2 times, we are sure that we are referring to the Google. So the 2 bills are for Google. And now if you have to use some customer ID here like 3, Apple is there. If you want to use 4, there is no record. So the constraint on customer ID in this new table is that it is only 1, 2, and 3. You cannot have more than this or any other than this. This is called referential integrity constraint. Operations in relational model. I think these are simple mathematical operations. You can correlate with them as a mathematics. So select is identifying one user. Project is multiplication. Product is again multiplication in Cartesian product. Union, like joining without repetition. Intersection is finding common things. Difference in taking from the left side, like R minus S is the set of tuples which are in R but not in S. So then joining means both the tuples are taken from both the all the tuples are taken from all the tables. These are relational model concepts. Best practice for relational model are data need to be represented as a collection of relation. Each relation should be depicted clearly in the table. A row should contain data about instance. 2 rows can be identical. 2 rows cannot be identical because of key values. Like in case of Amazon, Google, we have identified each one with a key. So there is 1, 2, and 3. There could not be repetition of 1 and 1 again. Advantage of relational model. There are various advantages like simplicity, structure independency, easy to use, query capability, data independence, and scalability. Almost some of them are common as advantage of database, like scalability of database is available in the relational model also. Disadvantages are still there, like free relational database have limited on field length which cannot be exceeded, like 255 is limited for small type of data. So category of data has to be defined based on the requirement. Relational database can sometimes become complex as amount of data grows. data become more complicated. In this case, we have to handle or take data in multiple tables, and better way to access the table should be developed. Complex relational database system may lead to isolated database where information cannot be shared from one system to another. When the database size grows multifold, we have to take care while copying or taking backup. All things are little complex in that case. Now we will see how sample queries are executed on the database, relational database. These are few example details in which a company transactions are shown via credit card, zip code, and complaint ID. Now, if you want to know the complaint ID, product, company, zip code, these are sample. Where again we want to find all transactions which are related to only one zip code. Here, zip code is given, so we are identifying only one. So again, it is limited to 10. So this is one example how to write a SQL query. So this is the output. All zip codes of 91701 have been taken out from the main database table, and it is again limited to only 4 columns because we selected only 4. They are complaint ID, CCD product, CCD company, and zip code. So these 4 things are taken from the main CCD table. Again, they have been limited to select only which have zip code 91701, and finally limited to 10. So it is less than 10, hence it is shown only 7. These are methods to identify the data from the database tables based on our requirement. Now we will cover up the third part. Special data types, special relations, special queries. Now we have come to the third part, which is directly used in WebGIS applications. So let's go through them. As you have understood basic database and database types, now we have come to the special data types. There are only 3: point, line, and polygon. Points are represented in 2 real numbers, which is coordinate of the point in geometry. Line is sequence of points. Region, area included inside endpoints. So there is sequence of points which covers the area. In these 3 ways, we can cover everything about the special data types. Special relationship, topological relationship, in which adjacency, inside, disjoints, these are the commands which we can find directly to find topologically when a satellite image is given, in which we have to identify whether the image contains this point or it is inside the image points. So the covered area, which topologically we can find whether it contains an adjacency like nearby, or inside like inside a covered area, or disjoint like different or not connected at all. Another type of relationship is direct relationship, in which we say that it is above, below, north, south, etc. So based on the database set, we find whether this information or this point is above this point or below the other point or north of the other point, like that. Third is the metric relationship, in which we find the distance, for example, and it is less than 100 or more than 100. These are third type of relation, and operations in to express the relationships. So these are all about the special relationships. Special relationships, for example, we will try to understand with the diagram. As I told, topological relations like containment, overlapping, etc. This example, we have seen that A is the area in which B is sub area. So B is containment with A. So A is containing B. Overlapping, A and B are overlapping here in the second diagram. Metric relationships to find the distance between objects. So A point and B point, like graph theory, we can identify the difference because we know that both the points. These are data recorded from the satellite image, which is stored in the database. Direction, A is above B. Here, this could be again identified based on the satellite image data in the database. So these are the spatial relationship data sets. Now, how to write the queries for spatial data queries? We can write like select query, find all objects inside the query queue. So inside, intersect, north, nearest neighborhood queries, find the closest objects to a query point Q, K closest object. Spatial join query, two spatial relations like S1 and S2, find all pairs. So relation is intersect, inside these things could be identified as I shown in the last diagram. Again, indexing, point access methods versus special access methods. These two methods are used for indexing. Indexing via point data is hierarchical structure, multi-dimensional hashing, space filling curves. These are the methods used. In case of special access method, index both points and regions. So transformation, overlapping region, clipping methods, this could be used. Vector data indexing, different indexing methods are used for point, linear, and polygon data. In the case of collections of polygons, instead of indexing the object geometries themselves, whose shapes may be complex, we consider an approximation of geometry and index it in C. So instead of covering the complete data set, we will find approximate data set and we will index that. So what happens is approximate idea, like in this example, we have shown the graph here. This geometry is not exactly rectangular, but what we have done, we have approximated this geometry as a rectangle. Now what is the advantage? This is most common approximation method in which minimum boundary rectangle MBR is called MB box. So what we have done is minimum bounding box is made. Now if anything is searched or found, we have a query like whether this point belongs to this inside this or disjoint of this, then we can find it based on the coordinates of this rectangle with an approximation. As you know, the spaces, blank space is also included in this, so there is some approximation criteria. Now, how MBR works? In case of point, see, X and Y point has to be found here, so XY coordinates are given. We have tried to find whether this is included in this geometry or not. So to find it, we have already MBR, which contains the rectangle. Now XY point we have identified as inside, and in the real region also it was inside. So there is proper approximation. It was true approximation. Spatial indexing methods. The popular indexing techniques used in the practice of industries. Standard relational database models are quad tree, octree, UB tree, R tree, R plus tree, R star tree, Hilbert R tree. And two methods are most popular in this are R tree and quad tree. R tree is based on MBR, which I have already explained. Define the indexing in 2D objects, as we have seen in the rectangle format. MBR of geometric objects form the leaf of the index tree. So multiple MBRs are grouped into large rectangles to form intermediate nodes in the tree. This again we will understand via diagram. It is repeated until one rectangle is left that contains everything. So what we have done in the last slide, we have MBR approximation method. We have extended this for the complete image. Let's see. We have here 9 images. This is a real type of example, satellite image which contains 9 different images. Now we have to group them in such a way that it could be stored, first thing, it could be stored in database properly, and second thing, it could be indexed so that we can find it when we need it. And third thing is we can run all the type of queries which could be possible on this data set. So the key point is how to store it and how to enable it indexing, then how to run the queries on the index or the database. Let's see. First thing, we have made MBR approximation and made them in rectangle format, and we have pointers in geometry. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have made it. Now we have grouped this set, named it as A. Second set B, third set C, fourth set D. And again, same way we have grouped them. So there are 3, like 5, 6, and 7. They have been grouped as C. Now let's move on. So we have another grouping, the third level grouping for R and S. And this is final grouping, so it is called root of the tree. In this structure, we have a control over the data set of the images which are received from satellite. We need to find something in case the point, whether it belongs to the region 3. If we have to find like this, what we have to do is we have to simply start searching from the root, go to R, go to B, go to 3, and find it in the geometry. This structure way is called R tree. DBMS 3-layer structure. It works with special applications, front end and database in the back end. It has 3-layer interface of special application, core special functionality, and interface to DBMS. Here we have developed some application for WebGIS. What we have done is application has been developed as a website. So front end is running as a login password or as very nice display page. But what happening in background? The data set received from the satellite is being stored in the database, which is called here as DBMS. And between these two, there is some core special functionalities being applied via interface to special application and another interface to database. What we have done in the core functionalities: taxonomy, data types, operations, query language, algorithm, and access methods. So all these methods are combined in the core special functionality. The organizing and managing of geospatial data inside DBMS or RDBMS has emerged as an exciting challenge for GIS professionals during the last decades. This study is called Spatial Data Management System. For this, there is different models, like we have a relational database model for other type of databases. For geodatabases, we have geodatabase model. The common storage methods and database used is one of the framework is ArcGIS. It combines spatial data like geodata and its management system. It can leverage in desktop, server, or mobile environments and allow to the users to store GIS data in central location for easy access and management. This is one example of geodatabase model. Single user, GIS data, multiple users, for them functionalities there, applications are there, geodatabase archiving is there. Like as I explained in the database relational database model, archiving is to store in a compressed format which is not available at the live location, so that we can have faster indexing and searching. Special data entity creation, like we have created a table for student record. In case of special data, we have to create record for a country. we have to use in such a way. So create table, name, state, population, shape. Here, other three items like name, state, and population are common type of variables which are used in relational database also. But the shape format is different. It's polygon, which is not used in generally relational database models. So what we have to do is create a special database model for this and store the polygon. Shape could be line string here, for example of river. And how to query them? The way which we have queried earlier in relational database model, we have used here where touch command. The condition is touch. So whether it is touching, the shape 1 and 2, we have tried to find whether they are touching. And the name condition also applied in this query, that it should be Contra Costa. PostGIS model is again, PostGIS is specially enabled. That means the database which is enabled to work with special data sets. Special data sets we have just explained. In PostgIS model, we used PostgreSQL, which is a SQL like MySQL type, but it have features to store special data. So for special database, we always use PostgreSQL as we use normally for relational database MySQL. So its the frequency of use is more as compared to other type of database, and being free or free to use. So most of the students will follow using the PostgreSQL while creating the websites or services for space related applications or database of satellite data related applications. PostGIS follows the OpenGIS standard. So simple feature specification for SQL. It can be certified as compliant with type and function profile. PostgreSQL is released under GNU license, so everyone can use it and modify it according to their requirement. PostGIS continues to develop by a group of contributors led by projects steering committee, and new features continue to be added. Type of queries in PostGIS we can find directly with distance command to find the distance. The output will be in number. Equals, which again to find whether the two geometries are equal. Disjoint, whether the geometries are not connected. Intersect, whether they are connected somehow, intersecting each other. Touch, to find whether the two geometries are touching each other. Crosses is also to find two geometries whether crossing or not. Output will be again Boolean here. So these are the type of queries which we can write on PostGIS based on user requirements. So these features are available in this spatial database management system. Additionally, overlapping of geometry, whether the geometry is contained within other geometry, intersecting with other geometry, to find length of the geometry, area of the geometry, and centroid of the geometry. This could be commands could be executed and found in the PostGIS applications. Special database applications, GIS applications for finding map, like urban planning, route optimization, fire or pollution monitoring, utility networks. All such applications via special database applications, in case in front it will be visible as a simple website, but in the background the database running will be a special database system, and the application, its optimization will be done by the management system of the database. Other applications like VLSI design, CAD/CAM, model of human brain, etc. These things, because it contains different type of data which is not available in relational database model. Traditional applications like multidimensional records, which could be like images of people, images of location. These are other further traditional applications. Thank you. Thank you, everyone.